Welcome everybody. My name's Scott Hebbard and I'd like to welcome you all to the Enterprise Architect 16 webinar series. Today our webinar topic is entitled Using Scenarios to Create Detailed System Specification in Enterprise Architect. I'd like to welcome everybody here and thank you very much for your attendance. So I'll just start off with a bit of brief housekeeping. We'll discuss how to submit questions. We'll then discuss how to create a system specification utilizing scenarios. And I'm going to let Nithya conduct a presentation in Enterprise Architect that will show us how that all works. And we'll be using an Enterprise Architect model and we'll show how that can be used to perform functional analysis. And at the end of the session, we'll follow up with some Q&A from the audience. So please note that audio is muted for all participants. So you'll be able to type questions to the host. And as always, if you can't answer all questions live, we'll follow up offline. We typically like to publish on the webinar on YouTube within 24 hours, and then usually a week later we publish on the Sparx Systems website with responses to some of the questions. So the questions box appears on the right-hand side. So simply enter the text and hit send or hit enter on the numeric keypad, and then it'll come through to myself. And once again, if we can't get to them during the live session, we'll follow up offline. But right now, I'd like to hand over to Nithya, who's going to present our webinar on using scenarios to create a detailed specification in Enterprise Architect. So I'll hand over to you, Nithya.
Thank you, Scott. Welcome, everyone. Hope you're all enjoying the day or evening, wherever you are. It's yeah, it is very cold here in Ballarat. How are you, Scott?
I'm very well, thank you. Would you like to share your screen, and I'll let you know when it comes up. Lovely, I can see the learning points.
Fantastic.
So I'll hand over to you. Thank you very much, Nithya.
Thank you, Scott. My pleasure. So without any further ado, let's get into the webinar. So the learning points for today's presentation is how to create the system specification using scenarios, and then do functional analysis with the created scenarios, and then to do what if analysis and find out the missing interactions and requirements as a result. The process we are going to follow is firstly, when you want to capture requirements, we begin with engaging all the relevant stakeholders. So we have to work with the stakeholders, identify the interaction between the actors and the systems. So when we say scenarios, it's all about the interaction between the actors and the system that is about to be developed. Once we identify the interactions, we can capture the requirements from these interactions, right? And then we have to improve these requirements. That's where we have to model the scenarios. And once the sequence diagram, using the sequence diagram, we can analyze if all the interactions are working the way it is supposed to work. Are there any missing interactions, etc. And once that is done, we can verify the requirements using executable state machines or any other way that you want to verify the requirements. For today's example, we are going to use state machines. And then we identify the missing interactions, if there are any, and perform what if analysis. This is the basic structure of doing functional analysis through scenarios. So this, the approach that I'm taking for this webinar is basically referenced from the Agile Model-Based Systems Engineering Cookbook by Dr. Bruce Powell Douglas. It's a great book. Now I'm going to take you into the model. I'll open the EA model, which we are going to use for the webinar. So Scott, can you please confirm if you're able to see the EA interface, EA model?
Yes, the EA model looks good. I can see the tab open, and I can see the properties on the right-hand side. So looks great.
Fantastic. Thanks. So to capture requirements. First thing, using scenarios, first thing we have to identify the use cases. And this is the basic flow of the process through which we are going to do the functional analysis. I'm going to open another diagram which will, yes, and take us to the different parts that I want to show you in the model. So what I'm going to do is adjust the screen a bit so that you'll be able to see all the different parts. All right. The first thing is identify use case. I'll get into the use case model. So this is a very basic use case model. So where we identify the actors, and these are the use cases, basic use cases. The example here is about a virtual system to train bikers, that is for cycling events. Okay, so that's the example. So basically there has to be a configuration app where we configure the bike, the virtual bike, and then there's a rider who will actually physically set up the bike and all the gear changes and all the parameters has to be set up here. And I'm not a professional rider, so don't ask me very technical questions about riding a bike, okay? So here, and then there has to be a training app. So these are the various use cases here. First thing, change the gear. Then we have to measure the performance metrics so that the rider gets better, they can challenge themselves. And then how to control the resistance of the pedal, adjust the inclination, etc. So this is a basic use case model. However, when we start developing a system, we first identify the epics and then decompose the epics into finer user stories, right? So when we take that approach, we can have epics like, set up our physical bike, communicate with apps. This is an epic again, and then configure the bike for the rider, which we got from the basic use case model, and then the emulate gearing. Okay. In the emulate gearing epic, we have decomposed into 4 different use cases: emulate basic gearing, emulate front and rear gearing, emulate mechanical shifting, and emulate gear shifting. For the case of this example, I'm going to focus on emulate basic gearing. Okay. So we have identified the actors. I will also open the actors diagram where these are the different actors that are going to communicate with the system. Basically, the training app, the configuration app, rider app. Training app can be any different training apps that can be integrated with the system you're developing. So these are the actors. So now that we have identified the use cases and the actors, okay, one more thing is you have to describe the use case, right? So let me go into the description, and then here's the description. So basically, emulate basic gearing will provide the rider with the ability to manually change gears, to change effort and cadence under a constant basic load, to simulate the ride feel. And here's the detailed description. So whenever there is a gear change, the system should emulate so that the rider will feel like he's in the virtual condition. Maybe he's going uphill or going downhill, and there are like potholes. There's there's rain, etc. You can simulate the entire environment, the virtual environment, for the rider to practice. So this is what this emulate basic gearing use case does. So once we have identified the actors and use cases, we go on to define an execution context. So we know these are the systems, these are the actors, and these are the use cases. And then how does, in an execution context, how things will have to function. What are the different blocks that we need? So this, in the execution context, we have the blocks. So the use case emulate gearing, basic gearing is defined as this block with the UC underscore appended in front, and then the actor is a EGB rider and then a EGB training app. As we saw, there are 2 main actors interacting with the system. And then now we have these blocks, and there has to be interfaces. So the interfaces between the actor and between the system and between the use case. Emulate basic gearing interacting with the rider, and the emulate basic gearing interacting with the training app. So there are like two interfaces. The naming convention is used so that we know which interface interacts with which actor. Hope that is clear. I'll move on to the connected instances. So now that we know these are the blocks and these are going to communicate with each other, what we have to do is to create ports between the systems. So these are the proxy ports within the training app and the rider app and the use case instance of the use case and the basic gearing, which is basically a view component. So now that we have the basic structure, right? Then we have to capture the use case scenarios. We'll go into the detail. Yeah. Yeah. Use case scenarios. So we have three scenarios. One is a normal gear change. There's no issues. The system is operational, and then gear change is happening, either incrementing gear or decrementing gear. The second scenario is the system is already at the maximum gear operational level. So what happens when the rider applies more gear, more torque? And then the third scenario is the system is at the minimum gearing level, and what happens when the rider tries to minimize the gearing, minimize the torque. So these are the three different scenarios identified. So let's get into the first scenario. So for this, we have used the sequence diagram, the instance of the rider, training app, and the emulate basic gearing, which is the use case. So these actors are interacting with the system using this interface. So the rider applies the torque, the system computes the resistance, and then the gearing, what gear it is, the current level is given to the training app. And then the applied resistance happens. It's a continuous thing so that the bike is, the rider feels the simulation of the feel of riding a bike. And then when the rider increments a bike, again, the system has to check the gearing and then change if appropriate. And then the gear level is again passed on to the training app, and then apply resistance. This is a continuous one. The resistance, the dotted line, is a continuous signal going to the rider. And then here's the decrement. This is for increment, and similarly, this is for decrement. Check gearing, change gearing, apply resistance. Okay, this is a basic scenario. Is there anything that is missing here? Do you think any interaction has been missed in this scenario diagram? Scott, any answers?
No answers at the moment, but
All
so
right.
change gear.
Yeah, let's go on to the other two scenarios, and then we will do a what if analysis. And then go to the second scenario where the system is functioning at the maximum gearing level. So now what happens when the rider tries to increment the gear, and then the system checks the gearing and it senses that the bike is actually riding at the maximum gearing level. So it will reject a gear change. So now, what will the rider think? Like, it's like I'm applying torque, but the gear is not changing. What is happening, right? So the interaction that is missing is from the system to the user that I'm already in the maximum level and I cannot apply more change to the torque. I cannot take any more torque. So this information, this interaction is what is missing. You know, I'm not going to get into the messages, describing the messages right now, I just wanted to let you know, so that's what is missing. There's an interaction, there's the communication gap there. Yes, whenever the rider changes to talk, the system responds, but when it is at the maximum or a minimum level, the system will not respond, but that message that I am already in my maximum capacity or minimum capacity, functioning in the minimum capacity, is not being given to the rider. So basically the interaction that the system has to display the current gear so that the rider will always have an understanding of which gear he's right now in, riding in. And then also when the gear change is rejected, why it's rejected, that information has also it must also be passed on to the rider. So that is the interaction that is missing here. So this happens when we understand, when we sit and analyze the requirements. Okay, this is happening. If I'm a rider, like what will happen? And you execute and say, okay, yes, it's all happening. Gear change is rejected, but then the rider has no idea why it's being rejected. So that is the missing part. So now that we have seen all these scenarios, what we do is we create from these interactions, we identify the requirements. So these are the 4 requirements. Leave the missing requirements for now. We'll come to that later. The basic interaction, what we got from the stakeholders, they say, okay, I'm a rider, I'm going to use the system, and I have to port it to one of the training apps, and the system has to simulate the virtual environment for me. So that is the basic thing, the mission, and then they delve into the interactions. We identify these requirements. Okay, the system shall respond to the applied pedal torque with resistance calculated from the base level of resistance, current gearing, and applied torque to simulate pedal resistance during road riding. So this is one requirement. Similarly, systems shall send the current gearing to the training app when the current gearing changes. This is what was missing. So the system shall respond to rider-initiated increase in gear, similarly decrease in gear, and that's a detailed description of the requirement here. You can read it. So these are the 4 requirements that have been identified. Okay. So once we identify the requirements from these interactions, I will open this for you. So identify requirements from the scenarios. We have come down to this step. So now we create the ports and interfaces in the execution context. So basically what happens is already created okay, introduction. Yeah, so here are the operations and the attributes required for the system to interact with the training app. Similarly, we have to create the the attributes from the training app. It will be like what is the applied torque, which is provided here, and then for the rider also we have to say like the gear, current gear, what it is. So this is how we go on going about the next step. Any questions so far?
There's just a couple of questions. Someone asked, will the model that you're using at the moment be made available so that they can perhaps have a look?
That is possible. Yes, Scott, I can
yes.
share the model with you, yeah, and you can publish it in the webinar page. Yeah.
And how do you go about generating test cases from the use cases that you're showing us before? Is that possible?
Absolutely, yes. So now that we have come to the requirements, it's a very valid question how to create create test cases. So this is emulate basic gearing. This is our example use case. So what we can do is actually okay. So this is a scenario editor. I've just typed in some random, it's not. I just wanted to check a few things. So this is a basic scenario editor. Using these scenarios, what you can do is once you create a detailed scenarios step by step, the happy part, the basic part. We created 3 scenarios, but for here in our example, have used the sequence diagram. If you take the approach of typing the steps here, the basic part, and then you can create an alternate part, etc. You can directly from this place, you can create test cases. So this will basically give you all the user acceptance criteria here, like what step, like each and every step here will become a test case. So that's a very easy way of creating test cases using the scenario editor. That is one way. Or if you want to type in your own, sit and type and manually add the use cases, the easiest way to do is I will actually use something called an inspector window. Go here and then I'll hit inspect. Okay, here it is. I'll hide the photos. And the inspector window will give you a detailed, okay, these are the details. So here's the relationships the use case is having. Are there any discussions, requirements, constraints, scenarios, etc.? So there's a basic part. If you want more, alternate part, part 2, part 3, you can add. And then here testing, you can add any test. For example, you want to add a new system test, and just add new system test. Okay. So system not go below minimum here, something like that. I'm just typing out. No, okay. Just apply. So now that is a system test. So when you open the test bench, you can identify, like you can assign the test case to a particular resource. You can see where it is, has it been tested, what are the results, etc. That's the easiest way. Any more questions, Scott? Hope that answered.
Thanks, Nithya. Just while you got that diagram open, I can see a whole lot of use cases all connected. Are there any other techniques for managing traceability apart from using the inspector window?
That's a good question. Can I come to that point when I discuss about the trace links, which is basically about traceability?
Yes, absolutely. No worries.
Yeah, lovely. Okay, let's move on to the next part where once, so we have the execution context and we create the executable state model in order to verify. Since we have a set of requirements identified, we will go for the verification of the requirements. Okay. All right. Now, verification of the requirements using basic gear change. Here it is. Here's the state machine for basic gear change. As you can see, there's basic gearing happening. It's constantly the system is operational, and then it's in a gear change state, and then the change has to be applied. For the sake of time, I am going to simulate this state machine in integrated environment. This is a simulation window. If you want to know how to reach or how to access the simulation window, there's a simulate menu in the main menu ribbon. Click on that, and then you will have the state machine simulation window. So just click on it, and then you get this window. All right, and I'm going to simulate. Okay, we don't need forget about this diagram. Okay, we are only talking about a state machine here. So just say. So as you can see in the bottom right corner, you see the simulation events and the triggers are waiting. Let's say I'm going to increment the gear. So there's a choice whether there is no change or gear increment change. Suppose say the system has detected it's already in the lowest point. I would say like no change. Then it will just go into the loop basic gearing. Let's say there is gear increment, and then the gear will be changed and then goes into the basic gearing loop. Same for decrementing the gear. That is negative gear, minus gear increment. If you notice, there's a minus symbol there. And then goes to the gear changed and then go to basic gearing. If the system detects no change, that it's already in the maximum level, and then I say no change, and then basic hearing. So this is an interpreted environment. So if you want to go into a more methodical and more intensive way, you can create a code to identify to and also give parameters which the gear increment level and check in a not in a manual way, in an executable environment. So that's another way of verifying the requirements. Okay, that is for basic gear change. So this is inside the basic gearing itself, like how the system is functioning. It is operational and constantly the rider is riding, and what happens at that moment. So I will just clear this and do a fresh simulation, and then the history, and then I click there's some gear levels, the idle state, yes, state copy. Then there's an apply torque is applied. When there's a change, goes to the torque applied. When there is no change, just go to the torque. Yeah. Do you see the system working constantly in the same way when there's no change? So that is what we aim here. So now that we have the executable state model, we have verified the requirements that the system works as expected and the interactions are happening as expected. We can move on to actually verifying and validating with the stakeholders. Like we have to always verify and validate with the stakeholders in order to make sure the system that we are going to develop will meet the stakeholder needs. So that will be this step. So when you go there, maybe the stakeholders might say, like, I want to see which gear I am in. So in that case, you can go into the master requirements and add more requirements here. The system shall display the current selected gear. The system shall default to a minimum gear during initialization. This might also be something the stakeholder understood after seeing the executable state machine, after seeing the after more detailed explanation. They have come up with these two requirements as well. So I'll just put it in the identified missing requirements here. This has to be in the requirements package. I'll just move them to the requirements package. It's just a diagram in order to explain that we identify missing requirements at this stage. So once the requirements are all there, and then we have the scenarios, what we do is we establish the traceability, because having a model repository is for it is to create one single version of truth, right? And it is also to will also enable you to do a very powerful impact analysis, a quick impact analysis, if you establish all the traceability links appropriately. Okay, so now the established traceability part, like how do we do it? Coming back to the question that Scott asked me towards the last question Scott asked. So this is one way you can have it in a diagram. Okay, so as you see, this is emulate basic gearing. That's the use case we talked about. In this example, and all the requirements we identified are here, and then each and every requirement are linked to this use case using the trace link. This is one way. Another way is, like, for example, if you're showing it to a stakeholder who's not really into modeling, he doesn't have the visual, it's not the visual type, like you don't want to see the diagrams, you can switch the view to a relationship matrix view, and then you can just say it's only with the target is requirement, and so the use case, and then this is just a relationship matrix view. This is just for the diagram. Another way is to create a traceability link using the relationship matrix, which is for the package level. Because the other day I heard someone asking the question, how do I create a model level relationship diagram? So here you go. So I can create this. Use case scenarios, the requirements, and use cases. Okay, package in the browser, and then find package has moved on to another screen. I will bring it back to the screen, and then okay, I go to the listeners.
And just while you're doing that, you can, of course, save a profile for this relationship matrix. So once you've done it once, you can just drop down the profile and access it instantly as well.
Yeah, absolutely. That's true. All right, this is another way to do it. All right. Have I missed anything? I think there's one more, which is called a traceability window. That is also a very useful tool. Go to portals and go to windows and then trace. Yeah. If you go to portals and windows and your job or current job, your aim is to establish traceability, you can just go to the portals and see, okay, I'm going to that my action is to have trace links. And now these are the different ways where I can establish traceability. So I click on traceability. This is the one I wanted to show you. So you can see emulate basic gearing has links to these model artifacts and what type of link it is, etc. So in just one window, you can see all the trace links for a particular model artifact or model element.
And Nithya, it's also context sensitive. So perhaps if you click on another requirement, you'll be able to show it.
For example, I'll just click. So good one, Scott. Thank you. So I'm generally focused on the requirement ESRQ0. I just say, okay, this is needed by this particular use case, and then you can drill down further. Yeah. All right, let's move on. So there it is. So now we have established the traceability. So everything that you need for a specification document so far, requirement specification document by a functional analysis using scenarios we have in this model right now. So the last step is obviously a documentation. So this is one I created previously, but I'll create a new one for you. Publish, go to this prevent publish, and then this custom document. I'll allow it in custom document because it makes my life so easy. So now there it is, system specification document for emulate basic, yeah. You can do for the entire, you can apply this for all the use cases if they are all models, and then create this, just move this diagram, create the specification document in a very simple manner. I'll show you. Say, for example, I want the actors, and say actors, a diagram report, have the diagram, and again, I want the I want a tabular note or description of all the actors. I will go and click on the technology, table name and notes, and I get this. So here you go. These are the actors, and if there are any notes, it will also be displayed here. So this is for the actors, and now I am going to do the same for the use case model. Now this, yes. At the moment, I will go with the diagram report. Just click this. There we have, and same with the model. Say yes. Not this use case as well. Say, for example, you've got that, and then yes, I'll say diagram report. Yeah. So we have all this report. Now I want to tag, or I want all the use cases in the table with the description. I will just go and create, select the template with the priorities. Now, here we have all the high level epics with the priority with different I'm sorry. Yeah. There you go. There it is. So, and now that we have the use cases, here, connected instances, let's just say I want the execution context. This time I will choose a model report. So you can select different templates and see like how you want the specification document to be, how detailed you want in a tabular level, or you want in a much granular level, then you go for a model report. So each and every element and the attribute will be described, will be added to the report. That is what I'm trying to show here. So all I'm doing is dragging and dropping and not typing anything at all. And once you create this document, you can absolutely customize it with some static contents. And every time something has changed in the model, all you do is to refresh the model, you refresh the document, and then it will be updated automatically. So this document will stay current every time you change anything in the model. You don't have to go back into the document and go retype, edit, etc. You don't have to do anything at all. EA takes care of it. So now that we have got this, let's also go and put some trace links there. And we go there. Did help? It work? If there's a diagram, matrix image, it would work. If I put it in a basic diagram way, so correct. There it is. And then, yeah, if there's anything more you want to add, you want to have a header, footer, etc., everything can be. So all I'm going to do is save it, Control S, and then I'm going to close the. So we have the document ready. Is that document going to be created? No, here we go. It's just not creating the wrong folder. I move it here and then click on it and save it, double click, there we go. And create it. Just to check
And if one of our customers would like that document in a PDF format, is it easy to produce?
Absolutely. All you need to do is publish. Once I publish, yes, and publish it as I've done that. Publish as see, there's so many things in A that I normally do, and I still yeah. There you go.
You can just press F8 on the element and export to PDF and a docx format as well.
See, I'm learning something today.
There we go.
Generate documentation. Yep.
And so you can include a table of contents and the output file. You can automatically set that to a different format, such as a rich text format or docx or PDF.
There we go. Yes. Hey, and then generate.
Sorry for interrupting, but it's in the model, but we can very easily get that out into a format that our customers like and use and need. And so that's done now, and you can view it in the model or externally. Yeah. And there it is. And of course, you can add your own templates and and table of contents page and, you know, company
Absolutely.
logos and all of that sort of stuff.
Absolutely. So with this, you can give this document to the stakeholders, and you can perform a requirements review and go through this process again if needed. So that's how we do functional analysis. EA helps in performing functional analysis using scenarios. Hope this webinar was useful and learned the ways to create scenarios and identify missing scenarios, how to do functional analysis, etc. using EA. I know in real world it will take a lot more time, but for the sake of presentation, I've already prepared a small model, and which is referred from again from the book Agile Model-Based Systems Engineering Cookbook by Bruce Douglas. With this, I'd like to conclude this webinar. Thank you, everyone.
Thank
Scott,
you,
I'm
Nithya.
open for any questions if there are any.
Yes, there's just a couple of questions, but I think what's interesting is that in a very short period of time, you've been able to show an activity diagram, a use case diagram, you've shown the scenario editor, you've shown how to automatically create a test case from your use cases. You've been able to look at a state machine and simulate the state machine so you can identify any gaps in the requirements there. You've shown requirements and how to verify and validate them. And you've shown traceability from the requirement all the way through to, you know, the end product. And then at the end, you've been able to, you know, generate out a documentation on the fly based on model elements and generate that out into a format that people interested in. So I think that's a really powerful demonstration of what Enterprise Architect's capable of in a very short period of time. So thank you very much.
Yes.
Just
Thank
to
you,
ask what
Scott.
might be an obvious question, but what version of Enterprise Architect are you using for this webinar?
Now I'm using the latest AE16. Scott, got a lot of new features in it, and yeah, it's more powerful and quick to perform simulations, and you know, there are a lot more features added to AE16 like scriptlets, which we will try and use it in the next webinar for the
Excellent.
series, Systems Engineering series. Yes. And also, our next webinar is going to be about dynamic behavior model simulation, right? Like,
yeah, absolutely, yes.
so if you
Dermot's
want to
presenting
know
that
more,
one.
yes, that's nice.
So
So if you want to know more about state machine simulation, I would recommend you to watch the webinar as well. That's more in depth. It has more in-depth detail on how to actually simulate state machines.
thank you. I've had a couple of people say they want to review, you know, the model and the video, and said, will the session be recorded? So yes, the session's being recorded. We'll try and make it available on YouTube within 24 hours. We'll send a email out with a number of links to things on state machines and activity diagrams and other elements to help get you started. If people do want to look at some of these things straight away, they can, of course, open the EA example model. And within the example model, there are use cases and test cases and requirements and lots of examples that you can look at straight away as well. So that should be quite beneficial. There was another question here just about the formats for your reports. So you can do a docx format, RTF, and PDF. So there's lots of options there. And there's some questions about custom templates and script fragments. So essentially that's what Nithya was showing on the screen before, where you can just drag and drop model elements straight into your scenario. So when we publish the Q&A, we might provide some links to some of the help file on, you know, how to create a custom document using some of those custom templates. So I think we kind of kept interrupting you during the course, asking about documentation and traceability and a few other things as they came up. So I think I've managed to.
That's fine. Like, yeah, EA is huge. I totally understand. It's comes with very
most of those
rich features.
Yes, and even when I gave the summary, you know, for half an hour to go from activity diagrams, scenarios, use cases, state machines, activity, traceability, and documentation. While it's amazing that Enterprise Architect can do it all,
Yep.
you know, there's a lot to go through, and I can understand why people might want to review the video to see, you know, how they add something on a sequence diagram, or how they, you know, can simulate a state machine or something like that. So I think it's fantastic how much content you've been able to present in a short period of time.
My
So
pleasure.
with that, I'd like to thank you very much, Nithya, for your presentation. I'd like to thank our audience for attending and for asking a range of fantastic questions, and look forward to seeing you next week for our next webinar, which you can sign up for straight away. And we'll also be sending out a few links and a link to the video so that everybody that's registered for the event can take another look. So with that, take care of one another, look after yourself, have a great morning, afternoon, night, whatever it is for your part of the world, and look forward to seeing you again in future. My name's Scott. Thanks, Nithya.
Thank you, everyone.
Bye-bye.
Bye.